Hi everyone, I hope you're doing great. Welcome to this video. I thought I could get back on and create a very simple introduction to Docker, and we shall be learning Docker by Dockerizing a simple Python application. I'm going to be developing a very simple REST API, which is basically a FastAPI app, and we shall be Dockerizing it or packaging it within a container. But before we do that, I think it's important we introduce Docker. What is Docker? Docker is simply a set of tools or a platform that allows us to automate things such as management or deployment of our application by use of a technology called containers. So containers are basically ways we can package our software into this lightweight, think of them as boxes that can keep everything from the runtime of our application. In this case, that's going to be our Python, the packages that our software depends on, for example, FastAPI, and databases and any other software that you may need to run your application. Now, the beauty about this is that when you have this set up, your application is going to run the same way it runs on your machine in a production environment. What do I mean? If you package your application inside a Docker container, all you need to do is to share the image, and then whoever has Docker will be in position to run your application the same way you run it on your local machine. The approach I'm going to be using in this video is one that's going to be basing on the practical bit of it, so I'll not go into the theory, but I will be explaining each concept as we go. So let us get started. To follow along, you'll need a Linux-like environment such as the one that I have right now, but you can feel free to use any environment of your choice. Those that are on Windows may use their CMD, those that are on Linux may use an environment like the one that I have here, and those that are on macOS will not find problems if they have Docker installed. So all the instructions are going to be left in the link in that description for installing Docker. So once Docker is successfully installed, we shall confirm that it's installed by running the Docker command. If this command is successfully running, then everything is running and set up successfully. So we shall see the multiple commands that are used for managing Docker. So to start, we shall need to set up a simple application. I'm going to start by creating a simple folder in my terminal right here. I'll use the mkdir command. So I'll create this folder and call it simple FastAPI to-dos. And once I've created this, I'll cd into it, basically changing to that directory. And once I'm done, I will go ahead and also make sure that my VS Code is open inside that folder. So all my work is going to be done inside the Linux environment that's provided by Windows Subsystem for Linux. So once our VS Code has been opened, the next thing we're going to do is to set up our simple application. I'm going to begin by creating a simple virtual environment right here. On Linux, you may need to install Python venv by using something like sudo apt install python 3-venv, depending on which Python version you have. But since I already have it, I'll just proceed to create the virtual environment with python 3-m venv and then env. So that will create our little virtual environment where we're going to install our dependencies. Once that is done, we're going to go ahead and activate it with source env/bin and activate. Now this is going to be different on Windows. You may have something like env scripts and then activate. So once that is done, we're going to install the framework or the dependencies that we're going to use. Since this is going to be a simple FastAPI app, I will run a simple standard installation of FastAPI with pip install FastAPI, and then I'll specify standard. This is done because I need all what the FastAPI will depend on and other extras like UVCon, WebSockets, and so on. So once this is done, I'm going to go ahead and create the requirements.txt file that's going to help us keep track of the packages or the dependencies of our project as well as their specific versions. So I'm going to go ahead and run pip freeze to requirements.txt. That will create the requirements.txt file right here. And once I'm done with that, we shall now go ahead and build our very simple application. So since we are building a simple FastAPI application, the first thing we're going to do is to create a folder. And that folder is going to be called source. To make it a Python package, I'm going to go ahead and create a file in it, which I'm going to call the dander-init.py file. So once I'm done with this, I am going to go ahead and import the FastAPI class. So I do not have the Python extension installed, but that's okay. So I'll just write the code. So I'll say from FastAPI, we are going to go ahead and import the FastAPI class. And once that is done, we shall create the FastAPI instance as app. So I'll just say FastAPI is going to be app. And that will be our FastAPI instance. So let's create a dummy API endpoint. So shall just say at app.get. So this is going to create the decorator that will help us to create the get method, which will take in the path that we want to access. And for us to handle any request, we shall need the route handler. So that handler is going to be called index, or let me just call it ping. So this is going to just return a simple response, which shall be a message, and then this will be pong. So this is just enough for us to have our simple FastAPI application. So for us to containerize this, we are going to need a Dockerfile. So a Dockerfile is a file that's going to be a blueprint or a set of steps that shall be needed to build our application into an image. So an image is what Docker will then transform into a container. So think of an image as what a blueprint is going to be, and then based on that blueprint, we shall construct a container, which is going to be a process on our machine that's going to run our application plus all its dependencies. So in this case, we are talking about the environment, which will be Python, any databases, maybe Postgres, and any other tools that we may install as our project gets bigger. So let us start by creating our Dockerfile. I'm going to create this, and this is going to be a file, which I'm going to call Dockerfile. Now this Dockerfile is going to be exactly Dockerfile. Any other spelling is going to fail. So I'm going to follow a bunch of steps to create a Dockerfile, and I'm going to be giving them numbers. So step number 1 is going to be to create the base environment. So the base environment is going to be like a setup of where we want our application to run. In this case, we're going to be installing the runtime for our application, which is going to be Python. And to do that, we're going to be making use of the command from, and then we shall have to specify a base image. So a base image is an image that Docker is going to have to locate on Docker Hub. Docker Hub is what GitHub is to Git, where we host all these images. So once we've built an image like we're going to build in this video, we can host it on Docker Hub to enable other developers or whoever may want to use it to access it and run it locally or any machine they may want. So for our case, what we're going to do is to tell Docker which image we want to use to set up Python within our container. So we're going to go ahead and do that with Python, and then we shall specify the specific version of Python we want to use, and that's going to be version 3.12 and then -slim. So what we have here is the from command, and the second argument to this is going to be the name of the image, or call it a tag for the image that's going to be used to create our base environment. So in this case, that's going to be our Python 3.12 slim. So once we've been able to do that, second step is going to be for us to create the work directory. So think of the work directory as a folder inside our container where our application is going to run. So this is where our requirements will be installed and our virtual environment will be created. This is where our code is going to be located, and this is where our application is going to be run. So we're going to set this up. I'm just going to say set up work directory. And once we have been able to do this, I think I've made a mistake. I'll just rewrite that. I'll just say Python 3.12 slim. All right, so I'll come back right here. We shall use the workda command, and that is what is going to help us to specify the workda. So we're going to call that workda/app. And once we've been able to do that, we now need to move inside our workda to install our requirements. So for us to be able to do that, we need to copy the file requirements or txt inside our workda. So to do that, we are going to copy our dependency list by using the copy command, and we shall specify that we need to copy this from the requirements.txt to our workda. So this basically means that we are copying a specific file, which is requirements.txt, and then the dot means that we are moving inside our workda and copying what we are copying inside that workda. So this will copy our requirements.txt inside our working directory that we've called /app. Once that is done, we're now going to go ahead and install requirements. So we shall run a command to install our dependencies. So to do that, we shall use the run command, and this run command is one that's going to make use of pip. So we shall do something like pip install. So we do not want to use a cache dash, so shall say no cache directory, and then we shall go ahead and read from our copied requirements.txt that's found inside our work directory. So this command right here is going to be in position to install all the requirements within our virtual, which is not a virtual environment, but rather our workda, so that when we copy our code and finally run our app, it's able to find all our dependencies installed. So once this is done, we are now going to go ahead and copy our application. So step number 5 is going to be to copy our app code inside our working directory. So to do that, we shall go ahead and still use the copy command to copy everything that we have within our local folder inside our work directory. So that's the point in saying ... We are copying everything inside here, inside our work directory. The problem is we have to ignore some files because some files are not going to be needed within our work directory. Such files are like the PyCache files that we may have within our structure, or any other database files, cache files, and the rest of the other files, things that you may even wish to ignore in a git ignore file. So to do that, we are going to go ahead and create a file called .dockerignore. So .dockerignore is going to be similar to what we may have for Git as the git ignore, where we're going to add files or folders that we may not wish to carry on to our Docker environment or our working directory. So in this case, I'm going to start with all files that end in PyC and PyCache files for our case. So in this case, I'm going to specify PyCache, maybe DB files, or let's say SQLite 3 files and the rest. So we may also do something like .SQLite 3. And yeah, those are some of the files we may want to ignore and not push to our working directory. So once we've done this, the next thing is going to be for us to expose the port on which we want to run our app. To do that, we're going to go ahead and, so I'll call this step number 6, expose the app to run the app, or the app on which the code, or let's say the app will run. So in this case, we shall expose the port. So if we're using port, let's say 8000, we'll have to expose it inside our Docker container. So to do that, we shall use the simple expose command. So we shall say expose port 8000. I'm going to just say expose port 8003 to just not keep it to port 8000, because I may have other services that may run on that port. So I'm going to save, and now finally we are going to go ahead and run our app. So this is going to be number 7. So shall run the app. So this is where we're going to specify the command. Now this is going to take in multiple arguments, and therefore we may pass them as a list or array of arguments. So to start, we are going to make use of the FastAPI CLI. Now before I run the app within our container or the image, we are going to run it locally here. And if you are familiar with the latest versions of FastAPI, it comes with the FastAPI CLI. This FastAPI CLI allows you to run your app without having to worry about the details of using UVCon and any other tools that run your app. So in this case, we can do something like FastAPI dev, and then we point to the folder or file we want to run. So source is a Python package, and it contains a valid FastAPI instance, and therefore by just specifying source, we can go ahead and run our app. So if we say FastAPI dev source, and we can go ahead and run our app. So if I say FastAPI dev source, that will go ahead and run our app, just like you see right here. Our app is running on port 8000. So if we run the app, we are going to see that it's running on port 8000, and it will return a message of Pong, just like you see right there. For us to run this with, let's say, a specified port, we may do something like FastAPI dev source, and then we provide the port argument. So in this case, our port is going to be port 8005, just like we have for our container, or the container we want to run in this case. So that will run it on port 8500 and 8005, sorry. So if we go ahead and run this, of course, we shall see that our app will then be run on that port, which we have specified to be 8005. Okay, so now that we have an idea about how we want our app to run, let us go ahead and use that same command to run our app. So I'm going to go ahead and copy this, and we may need to also bind it to the host, or to bind it to all network interfaces within our container. And the way we may do that is by basically specifying the host. So instead of using a local host, we may do something like source, and then we say host is going to be 0.0.0, and then the port is going to be 8005, meaning that we want it to be accessed on all network interfaces, including localhost. So that means we can access it on localhost, and yeah, our app will be accessed on localhost. So that's what you see right here. Okay, so let's go ahead and use this command. So it's the one that I'm going to copy right here, and it's the one I'm going to write within our Dockerfile. So each of the commands and their arguments are going to be strings, and these strings are going to be separated by commas. So if we have FastAPI being the command, we'll have to put it in quotes, and then comma, then the next sub command, comma, then the options or the arguments, comma, and the other options. So in this case, we shall provide host, comma, and then we shall provide the port. So our port is actually 8003, just like we specified with the expose command. So I'll change that to 8003. So this is what we need for our FastAPI app to run within a container. We specify the different steps that we may need for our app to basically be made into an image. So think of a Docker file as a file that Docker is going to need to build your application into an image. And after creating the image, it will then run a process called a container that will contain everything that will be needed for the application to run. So this process is going to be an isolated process, and it will run independent of any other processes that may be on the system. The beauty about this is we get to run our app and everything it needs inside that isolated process, meaning that in case we want to share this code, all we need to do is to just give the image to the person who has a Docker installation, and they'll be in position to go ahead and run the app locally without having to deal with any dependencies issues or any issues because the app will run the same way. So now that we've constructed a Dockerfile, let's go ahead and transform it into an image. To do that, we're going to go back to our terminal right here. If I ls or list whatever is inside here, we have our source folder, our requirements.txt, our virtual environment, as well as our Dockerfile. So we're now going to go ahead and use our Docker CLI to create our simple image. To build our app into an image, we're going to be making use of the docker build command. And what this takes in is the tag, or it takes in a variety of options. But in this case, if you want to find them out, you just have to say docker build help. And in this case, what we need to do is to provide the tag. So we're going to be using the -t. So the tag is basically a name, which is going to specify what we want to name this. So for our case, we are going to build this and give it a tag of, let's say, we're going to give it a name. Excuse me. So the name of this image is going to be simple FastAPI app. And then we can give it a tag of, let's say, version 1. So the name is the name of the image, which is basically FastAPI app or simple FastAPI app. The tag can be different depending on what version of the image we are providing. If we're to go back to our Dockerfile right here, when we're setting up our base image, we have Python being the name of the image we want to use, and then we may have different tags for the Python image. So in this case, we have Python 3.12 Slim, but we can have different other names of the images you may want to use within your project. Going back here, when we press enter, we now have to provide one necessary argument that we have missed, and that's going to be the Dockerfile. So for us to specify the Dockerfile we want to use, we're going to go ahead and run build the tag, and then we have to specify dot because our Dockerfile is located within this folder. So if I run that, you're going to notice that this is going to go ahead and follow all the steps that we have within our Dockerfile. First, it will go ahead and fetch the image from Docker Hub. And after fetching that, it will then follow all the steps that we created in our Dockerfile, including creating the work directory, copying the requirements.txt, installing our requirements, copying the application source code, and then going ahead to build our container. So one thing I've noticed here is that we have one warning. So JSON arguments recommended for CMD to prevent unintended behavior. So it seems like we have a mistake. If I'm to go back here, I made a mistake. I did not provide a comma. So you need to be careful about things like that. All arguments and all things within a command have to be comma separated in a JSON-like format, just like we're being told by Docker. So what I'll do is to go ahead and rebuild it to fix that mistake. And then all the steps that we've defined here are going to run, and we shall have our image ready. All right, so our image has been made. So to confirm if this has been made, we need to run the Docker image list, or in short, this can be Docker image ls, and this will basically list all images that we have within our system. Now, the thing is, we've already given this a tag, so the name is going to be simple FastAPI app, and then the tag is going to be version 1, just like you see right here. So this is beautiful because all we need to do is to go ahead and now use this image and then run our container, and that's going to be the next step. All right, so at this point, what we've done, we have created a Dockerfile, and we have defined how we want to build our app into an image. So for us to be able to build this or to run this image as a container, as a process of its own, we'll now have to go ahead and do something like Docker run. So Docker run is what will get the image and then run it as a process on our machine. So if we do Docker run help, we shall see the different commands that are involved when using Docker run. So this will go ahead and create a container and run it from an image. So an image is built from a Dockerfile, and then a container is going to be run or created from an existing image. Now what will happen is when you run docker run, it will go ahead and look at our local environment to see if there are any images that exist with that tag that's specified or the name that's specified. And if it does not find it, it will then go to Docker Hub, fetch it, and then run it. But if we have it just like we do right here, we are going to be running it directly. So let's go ahead and run our simple image. So in our case, we are going to go ahead. Let me first confirm what we want to run by doing docker image ls. So we want to run FastAPI, simple FastAPI app, and then version 1. So in this case, to run that, I'll have to just say docker run, and then before I run it, I'll have to specify which port I'm going to be running it on. For our case, I'll specify the port to be port 8500. So this is basically mapping Docker's 8500 to our local 8000. I think that's 8300, 8003 or 8003. Yeah, that's what I needed to do. So I'll map the Docker 8003 to our local 8003, and then I'll specify the name of the image. So in this case, that's going to be our simple FastAPI app. If I run this, we are going to go ahead and, so it's not going to run that. So I think I have to go ahead and specify the name of the tag, which is version 1, and that will be in position to run our image. All right, so we can now see that our app is running, which is good. So what we have here is a process, and this process is what they call a Docker container. To confirm that, I'm going to open up a new terminal. So I have to access my Windows subsystem for Linux. And once I'm done with that, I'll go ahead and try to run a command called Docker PS. So Docker PS is going to list all running containers, and in our case, we are now seeing that our container is this with a container ID, and its image is simple FastAPI app version 1. So the command that's running it is our FastAPI dev source blah blah blah, and any other information that's related to this image, just like you see, or this container, just like you see right here. So that's amazing. We've finally been in position to run our container. Now, the thing about that is we can be able to start, or we can be able to stop the container. So to do that, we can do something like docker container ls, and that will show us our running containers. If we are to do something like docker container stop, and then we specify the ID of what we want to stop, that will go ahead and stop the running container. So even if we are to go back this side, we shall notice that our container has been stopped. We can be in position to also delete containers. So just like we did the ls to list the containers, we can be, so since no current running container exists, we cannot get any containers. So let us just go ahead and run it. So I'll do something like docker run, and that will run our container. And once our container has run, we can now go ahead and run our docker container ls. So this will show us that our container is running. Now, we can do very many interesting things with this setup. For example, we can try to run terminals or execute commands on our app via the docker CLI. So you can do something like docker exec, and then you provide the container ID. So I want to run an interactive terminal. So this is what I want to provide as my arguments, the first one being interactive and the second one being a TTY, which is basically a terminal. So I'll provide a container ID, which is that, and then I'll provide what command I want to run inside there. So in this case, that's going to be bash. Oh, sorry for this. Connect my computer to power. So if I run bash, I shall get a terminal that is running inside our application. So if I do something like ls, we are currently inside our work directory, and we can be in position to view all the files that are found within our source folder. This is cool because if we have things like running migrations, all of those can be done within our virtual environment inside our work directory. So this is what I wanted to show you. I will be making other videos about Docker, but please use Docker and make it part of your life. So let us actually go ahead and run our app. So since we've specified it to run on 0.0.0, it will be in position to run even on our local host. So if you go to our browser right here and try to refresh, it's now going to go ahead and run that. I think I have a terminal running the app on 8005, so I'll stop that and then run our app on port 8003. So I'll do this with 8003. Yeah, and now our application is going to be running. Alright, thank you for watching this video. If you've enjoyed it, please leave a like and do not forget to subscribe if you're new. I'm going to be making more videos about Docker, and we're going to be looking at more advanced Docker concepts in later parts of the video. I will be using Docker in many videos to come, and please subscribe to the channel. Do not forget to like. I'll see you in the next video. Thanks for watching.